Hello and welcome. Because of my experience in working with AI search for the last couple of years, I'm often approached by recruiters for roles of this nature, and often they ask me how it ties back with the emergence of LLM and AI development. So basically, just want to shed a bit of light on that. Before we go too deep, I'll just give a bit of the background in regards to the data and the setup. So at the moment, the data is sitting on my desktop. It could well be in blobs, it could be in SharePoint, pretty much anywhere. But the process would be exactly the same. So in terms of the data, it's supposed to represent um, legal cases or legal documents because that's what I last worked on, and these are quite realistic. The data is actually generated by LLM sitting on my desktop. So at the moment, I've got Facebook Meta Llama's model sitting on my desktop in LM Studio, and I've actually written the code to prompt it to generate the legal documents for me. So just grab a bunch of names, first name, last name, roles, and then instruct the LM to create some legal document realistic with a number of characters, and pretty much it's all there. Now, the next steps after you got the document is you want to index it. Now, you can use a number of search engines to do so. I'm more familiar with Azure AI Search, but that costs a fair bit. So I'm just running for this experiment anyway. I'm running it locally in Elasticsearch on my local desktop. But the process will be exactly the same. So that's your vector there. The vector is the numerical representation of the strings or the contents of the documents. And as you can see there, you've got metadata. Now, that's absolutely critical to enhance your search, but I won't go into details too much there because that's quite involved. The other thing, probably of interest, is how it looks like. So I'm not using Neo4j, which is a graph database here, but I'm just for the search anyway. But I have indexed this into Neo4, and this just shows you the relationship between the documents and how complex it can be. So this represents a case in our folder and the various documents there. So that's the data there. What I wanted to show, if I still got the query here. So here you've got a bunch of data, right? And this is, I'll share this next time, but for now I just want to query here. And the reason why you want to use Neo4j, and the reason being is when you're conducting a search on a document, you're searching for the contents in a document. Now, sometimes you want to search something in a cluster and the contents in that document that may not surface in the search result. And for that reason, you want to use Neo4j. And so if you're searching for example, the keyword, I don't know, murder, and it exists in all these documents in green, but it doesn't exist in there. Now, without using Neo4j, you're not going to be able to find this related document, right? So this is the reason why you want to use Neo4j. It really improve the search. And apart from that, it's not just missed document. The other problem that you may face is, okay, let's say you've got a whole bunch of documents. You're searching for John Smith, and there could be hundreds of John Smith. Now, if you're doing a search in using semantic search only, it's going to return way too much document. So using Neo4j is going to let you reduce the number of irrelevant search results. But as I said, we'll talk about it next time. So that's just a bit of background there. Now, in Azure, the models. Now, this is Azure Foundry, whole bunch of documents in there. In my personal view, it's great, but not as great as I thought. But that's for another discussion. But in terms of the models that we're using, these are my choice. I need these ones to do my vector embeddings. I like using GPT-4 or even the Turbo one. And DeepSeek is really great because it's free. or Meta. So I use the cheaper ones depending on what's required. Now, in terms of the actual application that we're looking at, this is what I have built. So basically, what it does is it goes and lets you chat to the LLM, but the source information is actually your documents and not the internet. So here, if you say you want to search for the Hussein family, and there's going to be a lot, what it does is it goes and does a semantic search for Hussein family, and in the background it's running through and it's pulled back 10 documents. There's actually a lot more. There's about 30 Husseins in my folder, but I'm just restricting it to 10 because that's enough to show what we're trying to do here. So it's pull back 10 documents, and here we can drill into it and see what the contents of the document looks like. And we can go and grab the documents, and basically that's the documents there. So yeah, yeah. Now, that's your first results. Now, what happens if you pull back a lot of documents, a whole bunch of it? Now, you could send all 10 to your LLM for summary, but a lot of times that's going to be prohibitively expensive because you don't know how many documents you're going to come back. So you want a mechanism to actually check on that. So saying I found 10 results, do you want to trim it down a bit, or do you want to send a full load? Here we've got 10 documents, Sam Hussein, Way Hussein, and so forth. I'll just say I want, I don't know, I want this one, Sam. Oh, sorry. I want Alpha Hussein. Now this is the interesting bit, right? So in the first time we ran it, it did a search on the vector database. Now, if you only return 10 results and you want to run a filter on a particular one, you can run it against the vector database, but that's going to bring up the cost of your search results because every time you make a hit in Azure or even Elasticsearch, if it's not run locally, there's cost involved with that. So basically, we've got 10 documents in the initial search, and since it's already there, and I just want to drill down on one, you don't want to go do another search because that takes time and it costs money. So what we did here was we ascertain what the user wanted, and we're using semantic kernel to determine or ascertain whether it's something we already have in memory because the search results that we got pulled back from for the 10 documents actually store in RAM at the moment. And I'm using semantic kernel not to, there's two types of memory. One is just RAM to store the contents of the documents, and I'm also using memory from semantic kernel, and that in contrast is to store memory for context as it should, because that will help the LLM determine the next course of action. So that's a bit complicated, so I won't go too much into it. But basically, what it is we're trying to bring down the cost um, in terms of scanning through the search engine as well as sending the results to the LLM like ChatGPT or whoever it is that you're using. So at the moment, we've got all 10 in memory from the initial search, and we're saying we want to drill down on one. It's found the one for you in memory, and it's done so using semantic kernel. It's actually going there and determining whether we got that in stock in memory. So semantic memory has found that information, and therefore we don't need to do another trip into the database, which costs time and money. So every time it hits screen, it means we found something in semantic kernel memory, and we don't have to hit it again. Okay, so at the moment, we've got one document. We found it and we sent it to the LLM for summary, and that's Alpha Hussein, and the LLM has summarized the document for us. Um, you can prompt it to give you a really dense summary or a very detailed summary. I just want something really very dense. I just prompt it to reduce the tokens. Yeah, so that's pretty important here. Now, let's say you want to search for case this time and not a person. Now, you could run that particular case, and this time I'll just make it a little bit more interesting. I'll redact it. I'll show you what the output of that in a minute. But at the moment, the other thing is we're using, for the backend, we're using ASP.NET Web API or web server because you need that to do all your logics and so forth. And it's connected to the web server with SignalR, and that SignalR is broadcasting all these messages down here for us for debugging. Now let's do our search now. It's just running in the background, and that's probably part of the reason why um, we don't want it to run too much in the search engine. So okay, this time it says it's found 4 documents. Before we found 10, we found 4 cost warnings. Do you want to send all 4 documents to LLM, high cost, or narrow down for a specific? Because we did a specific one previously. I'll say send all. And then this time it's going to send, rather than one document, it's sending the full documents to the LLM. And I've asked it to do the redaction on summary. Now, when you do the actual redaction, is quite important. Obviously, you don't want to send the redacted data to the LLM as you would just confuse it. So you send the original data to the LLM, and when he summarizes the results and sends it back to you, that's when you send another results to cognitive search to redact. Now, because we have chose to redact the data, it still summarizes correctly, except the key people have been, or the names, the personal identifiable information have all been redacted, but it still gives you the gist of the case. So instead of one document, it's grabbing all 4 documents, summarizing it, sending it back to us, and then we redact it via cognitive services. So that's yeah, that's pretty much it. I mean, it's quite powerful. It does a lot of things. We're just looking at Semantic Kernel at the moment, and a number of few other things. But the interesting part is when you need to secure this in Azure. Um, you would normally want to put that behind APIM to monitor the traffic and implement policies like throttling and so forth, because you don't want your users to all hack. If it ever gets hacked, if it does get hacked, you don't want people to keep on hammering that server of yours and build up a really big amount of cost. So that is pretty much it. Yeah, well, until next time, have you enjoyed it?